The raw material comes in extruded bar form, mostly round bar, but also some different shapes. All beaners are made from 7075 aluminium alloy, which also contains zinc and magnesium. 7075 is widely used in the aerospace industry, and we use it as it gives us great strength, toughness and durability. We also use two other alloys for some of our products, such as the larger cans and walnuts. The walnuts 7 to 11 come in extruded hollow bar form. This method gives a lighter product than hot forging the shape, and by starting with the extrusion we save time and money. We also have extrusions for part of the crampon heel clips, cam spacer bars, ice axe handles, etc. The first operation for most products is sawing the bar to length. This could be for anything from cams and ice axes to beaners. The sawing is an automated process. Once started, they can be left to run almost indefinitely. However, regular checks are carried out to ensure that everything is running smoothly. For beaners, the next jobs are annealing and bending. Annealing simply involves heating the bars up so that we're able to bend them without causing damage. The bars are then bent into the shape we want, depending on which beaner they are to become. Again, this is an automated process, but we randomly check 3 from every 50 bars to ensure the machine is still working correctly. This is where things get more interesting. Hot forging allows us to add all the features to our beaners. This is why we can make beaners incredibly light and strong and ergonomically efficient. Hot forging is essentially a stamping of the metal. The bent bars are all placed in a furnace and heated to nearly 500 degrees centigrade. They are then placed in the press, which stamps the features we want. As the beaners are so hot, it's easier to get the shapes that we need, although the forge still applies over 400 tons of force. The hot forging provides all the details of the beaner, the back, the nose and even the logo. The excess metal from the hot forging is then clipped off. This waste metal is sent away to be recycled. Heat treatment is one of the most important processes in the manufacture of climbing equipment. A correctly heat-treated beaner is about twice as strong as one which hasn't been heat-treated at all. Heat treatment is made up of 2 stages, solution heat treatment and hardening. The first involves heating the beaners up to around 500 degrees C, close to the melting point of the zinc, and then leaving them at this temperature for about an hour. This cooking changes the atomic structure of the metal. The alloy elements, the zinc and magnesium, dissolve and disperse uniformly throughout the solid aluminium. If the cooked beaners were then allowed to cool naturally, the alloys would separate back in their own groups. Instead, the beaners are quenched or rapidly cooled in water. The quenching locks the alloy elements into the aluminium. The next step is the age hardening. The beaners are placed in another furnace at a lower temperature, around 250 degrees C, and left for 12 hours. This allows the formation of precipitated particles, which strengthen the aluminium even further. Heat treatment is a difficult process because of the need for accuracy. For the beaners to reach their maximum strength, the furnace temperature must be exact to within 1 or 2 degrees, and the timing of the process must be to the minute. The beaners are now close to their finished shape. They now spend 24 hours being vibrated or rumbled in a machine with hundreds of ceramic chips. The rumbling removes any sharp edges left after the clipping process and gives a smooth finish. This is where the holes are drilled to attach the gates to the beaner backs. A wire gate needs 2 holes and a solid gate just the 1. Anodising is the only operation which we don't carry out in Llanberis. The beaners are sent to a specialist near Manchester. We are happy to contract out this operation as it's not strength critical. An incorrectly anodised beaner just looks wrong. Anodising is a dyeing of the metal and serves 2 main purposes. Firstly, it helps climbers tell their beaners apart. You can clip the silver beaner into your gear and the darker beaner is for your rope. Anodising also acts as a barrier against corrosion. If you climb a lot on sea cliffs, anodised beaners will last longer than plain polished ones. The beaner backs are now ready for assembly with the gates. We have wire gates, solid snap gates and 3 locking gates, screw, twist lock and lock safe. This is the end of the line, final inspection. Every product we make will be 100% inspected, visually, mechanically and a tensile test. This is where we carry out the final tensile test. The beaners are pulled apart on 12mm bars at a set speed. Beaners are tested in this way to ensure that they have reached or exceeded their stated strength. The force is measured in kilonewtons. This carabiner snapped at over 27 kilonewtons, the equivalent of well over 2.5 tonnes of static load.